Okay, let's look at this first problem that you missed, which was 1C, the drawing of the graph of f of 1 minus 2x. So your procedure here looks right. 1 to the left, divide by 2, and flip over the y-axis. Great. That looks right. And let's just check the... All right, let's go back to number 1 now, D. So what you have to do, let's see what you did before. You had the domain right. It's whatever's on the positive side, you mirror on the negative side. So it would go from -7 to 7. And an absolute value in y, well, right now the range is -5 to 0. But when you do the absolute value of that, the new range would be 0 to 5, which is exactly what you have here. So this looks good. Okay, yes, so 1 is now graph here on the next page. Whoops, didn't mean to draw on that. And let's see, yes, these points look absolutely right. Perfect. Okay, so yes, you've got that correct. All right, and that was the graph. All right, let's look at 2. Okay, so you have a question about 2a. Okay, so remember when we talk about the domain, we're talking over real numbers. So you can't have under the square root be negative. So I need 5x to the 6 plus 49 to always be greater than or is equal to 0. So 5x to the 6 has to always be greater than or equal to -49. Whoops. This piece of water on my iPad. And so x to the 6 has to be greater than or equal to -49/5. But something to the 6th power, to the even power, is always greater than a negative. So there are no limitations on what you can put in for x, because it will always result either in something 0 or positive. So the domain is all real numbers. Now for the range, okay, I've got the -2/5 outside. The smallest that can be under the square root is when the 5x to the 6 term is 0. So you've got the square root then of 49 to infinity. So when that x term is 0, you just are going to have 0 plus 49. So that's the small, and then otherwise you're just adding to 49. So getting bigger and bigger numbers. So let's do this out. We've got -2/5 times square root of 49 is 7 to infinity plus 3. And this would give us -infinity to -14/5 plus 3. So adding 3 to -14/5 would get us 1/5. So the range here is -infinity to 1/5. All right, let's look at your part C here. This looks good. I want to look at what you did before. Yeah, you just didn't actually simplify that the square root of 1 is 1. But essentially you had the right thing. Just simplify square root of 1. So yeah, it can't be 6 or 8. So this looks great here. In terms of the range, all right, I like the analysis. This is great. Just remember, -2, how you get the -2 is -2 over 1 with a bracket. So this should have a bracket on it, because it can include that value. All right, now moving on to D of x. Oh yeah, T of x, you just made a careless error. It was just, you forgot when you bring over the 2, it becomes negative. So that looks fine. Making sure that you understand 2, and then putting a bracket on the 2a of x, sorry, and then putting a bracket on that range of C of x. All right, let's look at 3 here. I want to look at what you did before. Yeah, I'm trying to figure out what you did. Not quite sure how you got your original, and because you have, oh, I know what you did. Yeah, so the main thing is here is when you, so going to the original problem, which you have up here. Okay, so you get x cannot be 4. which is good. You have the x greater than or equal to 1/3, which is good. Okay, so this piece you're still, oh no, this is fine. Look right here. So x is less than or equal to 47. Before you had greater than or equal to, maybe, at least that's what you put. Anyway, but this is right. And so now if I look at, okay, the smallest here is 1/3. So it has to be greater than or equal to 1/3. Can't be 4. And so it's everything from 1/3 to 47th except 4. So this looks beautiful. Okay, great. All right, things you just really want to look at. Now to 4. Oh, you're ordering on your quizzes. In the quiz you submitted via Canvas is a little bit backwards. Okay, yes, it's odd, right? Because if you factor out a negative from the top and the bottom, but the negatives cancel each other out and you get the same as the original. So yes, this is indeed even. Let's look at finding your, I don't know what you did originally, finding your inverse. You made it way more complicated than it needed to be, but this looks great now. 8/x minus 2 plus 1/3. Looks great. Okay, now let's go to 6. So yes, so same x-intercepts is indeed going to be number 1, because if you think of an x-intercept, well, let's just call some generic A0. If in number 1, that's multiplying the y value by 3. So when I multiply 0 by 3, there's absolutely no change. And that's the only one that'll be the case for. For C, it is 1, 2, and 3, right. And D is just 1 and 2, right. So that looks good. And I think that is it. Yeah. All right, so good job here. So really just, if we go back,